Good morning, class. This is the ECON 512 Introduction to International Trade class. Today is February 8th, Tuesday. The class will cover the second half of Chapter 4 of your textbook. The topics of today's Chapter 4 will include what is at stake in trade theories, and trade theory part 2, application of Heckscher-Ohlin theorem, and practical application and evaluation of factors models. So let's watch the video clips.
Study Heckscher-Ohlin theory of trade. So here is what we are going to study in this lecture. We will start with the production possibility frontier, and we will compare this production possibility frontier with the one that we studied earlier in a single factor of production, that was the labor in David Ricardo's model. Then next we will see the relationship among output prices and the input prices, or what we call the prices of the factors of production, the wages and the rents, and the level of inputs. Again, the relationship among the output prices, the input prices, and the level of inputs, the amount of factors of production that we are going to use, and we will see how much we can produce with those levels of input. Then we will see how can we trade in this type of model, the trade that is explained by the Heckscher-Ohlin theory. And finally, we are going to see the impact of such type of production on the income distribution. Does this theory explain the variation in income distribution within a country? Some people may benefit more as compared to the other group. So we will study that in our lecture. Heckscher-Ohlin model basically follows the theory of labor productivity, or also known as the theory of comparative advantage. Comparative advantage theory tells us that countries trade because they have comparative advantage in certain goods. And that advantage occurs because of the difference in labor productivity. Means that in some countries, labor are productive in producing cheese, whereas in other countries, labor are productive in the wine sector. So because of their difference in labor productivity, they are able to produce abundantly certain goods and then trade with each other. Heckscher-Ohlin theory basically does not reject the comparative advantage theory, rather aids to it. What Heckscher-Ohlin theory believes in is that it is not only the labor productivity that matters, but resource differences matters. In each country we have different resources, and that enables a country to trade. For example, if we look at Saudi Arabia, they are not rich in agricultural lands. They have a limited cultivatable land, but they have abundant oil resources. So Saudi Arabia will trade in petroleum products. And this is not because their labor is efficient in oil producing, but rather than they have abundant oil resources. Similarly, if you look at Pakistan, we cannot produce oil at that competitive level because we do not have sufficient oil resources, and comparatively we have abundant agriculture lands available to us. Therefore, we produce agricultural goods, and Saudi Arabia will produce petroleum goods, and both these countries will trade with each other. So basically, Heckscher-Ohlin theory argues that not only the difference in labor but the labor skills, the physical capital, the land, or other factors of production across countries create this productive difference. Countries have relative abundance of factors of production. Some countries are abundant in land, whereas other countries are abundant in labor, and some countries might be abundant in capital. So, all countries have different level of abundance in different factors. And again, production processes use factors of production with relative intensity. It means relative intensity basically means that in some countries, labor will be used more as compared to capital, whereas in certain countries, we will be using capital more as compared to labor. It depends entirely on the abundance of these resources. So when we want to discuss the Heckscher-Ohlin model, there are a set of assumptions that need to be understood first, and these assumptions are that we have two factors of production for the model. One we call the labor, and the second factor of production, that is land. We are ignoring all other factors of production such as capital and entrepreneurship. Then the second assumption is that the amount of labor services and the land varies across countries. Means labor and land will be in different quantities in different countries. They cannot be the same. There will be more labor in one country and more land in another country. Then the third assumption is that the quantity of land and labor will remain fixed in those countries. The total labor available in Pakistan will not change, and similarly the total amount of land in Pakistan will not change. It will remain constant. Similarly, it will not change in the other country that we are studying. This amount will be fixed. And remember that this is only an assumption. We may relax this assumption in order to understand the impact of these factors of production. What if we increase the factor of production in a country? What will happen? So for that purpose, we can relax this assumption, but the model overall assumes that this factor of production will remain constant. Then again, two goods will be produced, and we name those goods as clothes and food. No other goods will be produced in this economy. How will the price be determined in this economy? Basically, the prices are determined through competition. And whenever we use competition, we means supply and demand. So how will wages be determined? Wages in an economy will be determined through supply of labor and demand of labor. At whichever point they are in equilibrium, that will determine the amount of labor utilized in that economy and the wages that will be given to them. Similarly, it is true for land. The rent of the land is also determined through competition, through the supply and demand forces. And our final assumption for this model is that only two countries are model, and we name those two countries. We call one domestic country and the other we call foreign country. So basically, if you look at these assumptions, what you see that we have two factors of production, and then only two goods are produced, and only two countries are modeled. So this model, the Heckscher-Ohlin model, is also called cross-2 model. The production possibility frontier in our previous model was a straight line. For example, we had two goods. One we call clothes and the other we call food. PPF was a straight line sloping downward. But now the production possibility frontier will not be a straight line, rather than it will be a curved one. It will be curving towards the outside. So what is the basic reason for that? It is because previously we were using a single factor of production, but whenever we are using two factors of production, then marginal productivity of labor and marginal productivity of land both will come into work. The more you utilize land, the more the quantity of food will decline with the passage of time. Anyhow, we are going to discuss it in the coming scenarios. So let us first define some of the variables that we are going to use here. The first one is ATC. ATC is basically the hectares of land. T represents land, or alternately we call that terrain, whereas C represent its usage for the production of cloth. Similarly, the ALC represents labor used for the production of cloth. Labor hours used for the production of producing 1 meter square of cloth. Again, we define ATF as hectares of land used for production of 1 calorie of food, and ALF as hours of labor used to produce 1 calorie of food. L is the total amount of labor available for the production, and T is the total amount of land or terrain available for production. Remember that we have discussed in our assumption that the amount of L and the amount of T in the economy will remain fixed. It is important to note that for the production possibility frontier, both the factors of production are required. We will be using land as well as labor in order to produce the amount of cloth required and the amount of food that we require. So the basic equation for the total allocation of land resources is given as ATF into QTF plus ATC into QTC, which should equal to T. And it will be less than T in case we are not utilizing the entire land for the production of these two goods. But if we are using the entire land resources, then it will equal to T. Basically, ATF shows the amount of resources, the land resources for the production of food, and ATC into QC shows the amount of total land used for the production of cloth. Combining these two gives us the total amount of land that has been utilized. We can do the same math for the labor. Total labor utilized for production of food and total labor used for production of cloth. And this gives us the total labor utilized in our production. Now, we need an important assumption regarding the production possibility frontier. Since we have two goods, one is called cloth and the other one is called food. Now, the nature of these two goods is different. We consider cloth to be labor-intensive good, meaning that when we want to produce a unit of cloth, we need more labor as compared to land for its production. And for food, we need more land rather than more labor for its production. So we say that cloth is labor intensive and food is land intensive. The equation we can use for this purpose is ALC or ATC, which is greater than ALF or ATF. Let me rewrite this equation so that we can understand the statement more clearly. You know that ALC is the amount of labor required for the production of cloth, and we compare it to the amount of land required for the production of cloth. So this amount overall is greater than the amount of labor required for the production of food as compared to the amount of land required to the production of food. The equation simply means that labor requirement for cloth is more as compared to labor requirement for food. The assumption influences the slope of production possibility frontier. Now, when we want to produce cloth or we want to produce food, we can substitute the amount of labor for the production of cloth with certain amount of land. But let's assume that we are not able to substitute these two factors of production. If that is true, then we will get two independent production possibility frontiers, such as you see in the graph. The one is for labor and the second one is for land. How much we can produce depends on the slope of these individual constraints. Now the green area shows us our production possibility frontier. This is what we can produce. The red area also is producible, but that production is inefficient. So in such scenario, what we get a kinked production possibility frontier, and this kink is usually inwards. The production possibility frontier is different when the factors of production are substitutable. In this case, we get a curved production possibility frontier. Now, why is it a bow shape? The basic reason for that is that now we have two factors of production, and when keeping one factor of production and increasing the other factor, we have a decreasing marginal productivity. For example, we have factor of production of land, and we have the total output of food QF. Now, when we increase the amount of labor while keeping the amount of land constant, what happens? Our productivity increases, but as we increase more and more labor, our marginal productivity is declining. This marginal productivity, this decline in the marginal productivity of labor causes the kink shape. As we have discussed, we can use multiple combinations of input, that is the land and labor, to produce a single unit of food. But remember that this combination is not constant. For example, we may sacrifice 1 unit of land, and we may substitute that with half unit of labor initially. You see, we may substitute that with half unit of labor. But the more and more we substitute it with labor, we may ultimately need to change 1 unit of land with 3 units of labor. So the point is, in the production of each unit of food, unit factor requirement of land and labor are not constant. And you see, it is apparent from the graph that the slope is not constant. It is not a straight line. Isocont is not a straight line, but its slope varies as we try to use different combinations of land and labor. Now, the production possibility frontier tells us what we can produce. but it does not tell us the worth of that production. Let me draw the production possibility frontier here. For example, we have food on the y-axis and cloth on the x-axis, and we have a production possibility frontier. We can produce anything within this red line. Let me mark that with blue. We can produce anything in this area. We cannot produce anything over here. On the red area, we cannot produce anything. But if we want to produce efficiently, we'll be producing over the production possibility frontier. And we can have multiple points on the production possibility frontier. For example, this is point A, point B, and point C. All of these can be produced, but what is the worth of these points? What is the worth of these combinations of code? They will not remain the same. So we need to understand them. The production possibility describes the economy can produce, but to determine what the economy does produce, we must know the prices of these goods. In general, the economy should produce at the point that maximizes the value of production. If the value of production is maximum at point A, we will produce at point A. If it is maximum at point C, we will produce at point C. Otherwise, if it is maximum at B, we can produce at point B. How we know the value of production? It is given by the equation V is equal to PC into QC plus PF into QF. The overall value of production depends on the prices of cloth and the prices of food. The overall value of cloth is PC into QC. Price of cloth multiplied by the amount of cloth that we have produced, and then PF into QF tells us the overall value of the food that we have produced. Combining these two gives us the overall value of our production. So basically, it depends on the values of the PC and PF. PC represents here the price of cloth, PF represents here the price. Using the same equation, we can derive the ISO value line. What is an ISO value line? It represents a constant value for a specific production. So let us go back to the main equation that we have discussed now. V is equal to PC into QC plus PF into QF. Keeping its value constant, we may write it in terms of quantity of cloth or quantity of food. So taking food to the left-hand side and keeping the rest of the equation on the right-hand side, taking V to the right-hand side, we have our new equation as PF into QF equals V minus PC into QC. And again, dividing both sides by PF, we get QF and V over PF minus PC by PF QC. So this is a straight line. We get a straight line for ISO value, where value remains constant, and minus PC by PF, it is actually the slope of this line. Whereas V by PF, this is actually the intercept. V by PF will be the intercept of our ISO value line. Let us integrate this ISO value line into our production possibility frontier. Our first ISO value line, let us call that V1. This is possible. We can produce anything on V1, but this will be an inefficient production because it falls below the production possibility frontier. Let's say if we produce at point A, we are not utilizing our entire resources. Again, at point B, we are using more resources than before, but again, this is not efficient. At point C, our production possibility frontier is at its maximum. But what is wrong with point C? We are not producing the quantity that gives us the maximum value. But if you look at point Q, we have maximum value as well as an efficient production. Again, anything above that, let us say that we want to produce at point, we call it F. At point F, we are unable to produce. The value is more as compared to point Q, but that is beyond our production capacity. We do not have enough resources to produce at point F. What we can summarize from this discussion is that given the prices of output, a point on one ISO value line represents the maximum value of production, say at point Q. At that point, the slope of the PPF equals the slope of the ISO value line, and the slope of ISO value line is given by minus PC or PF, and this is also our opportunity cost. Our opportunity cost must equal to the relative price of clothes as compared to the relative price of food. In other words, the trade-off in production equals to the trade-off according to the two important key points that we have studied up to this point is that country will produce on its production possibility frontier because that is efficient production, and they will produce equal to the relative prices of the two goods, that is on the ISO value line. And the third important decision is, in order to produce that amount, how much of the factors of production are required. So they depend on the price of factors of production, and price of factors of production basically are the wage given to the labor and the rent given to the landowners. So again, it depends on the market prices of the factors of production. If wage rates are high and land rates are low, then firms will use more land as compared to labor. So this is enough for today's lecture. In the next lecture, we will continue with the remaining of the Heckscher-Ohlin model.
The specific factor model. Before I hit into the lecture, any questions so far? I know some of you already submit submit your homework a little bit earlier, which is good. And I try to respond to your answer as soon as possible. But I won't give you like very specific detail of each of the answer, because I want you guys to find out the answer by yourself. And most of them could be found on the textbooks or on the lecture slides. So before heading to the lecture, any questions?
Yeah, Professor, I got a quick question.
Yeah, go ahead.
So just to confirm what you just said, and I know you mentioned it at the beginning, but as we go on the homework, we can submit it to you, and you'll let us know if at least if the question is right or wrong. Is that correct?
That is correct. That is correct. And many of you, I think 5 students already submit part of their answer, and I will try to give you some of the feedback on the questions that you already write your answer on.
Okay, perfect.
So I will
Thank
just
you.
improve it, and I will tell you, oh, it looks good, it looks bad, and which part might have some of the mistakes, and which part you might make the mistakes, and like which part maybe you head to the wrong direction. So feel free, if you want to submit the homework via the Blackboard assignment section, you could do so, because I set the submission on the Blackboard, which is the unlimited. So it's an unlimited submission. You can always update your latest answer, just like what I did for the homework assignment. And you could also just email me. I think that's the best way, because I could just check my email and then open up the attach and then give you some of the feedback right away. I know some of you just send me your partial answer of the homework today. I apologize, I'm a little bit tied up today, so I will get back to you as soon as possible. Any other question? Okay. Oh, I just forget to share my video. Okay. If not, let's kind of a little bit review a little bit of what's the specific factor model. Okay, so we start with the assumption of the specific model last time, right? And now we have 2 countries once again. And we have 2 sectors. One is called manufacturing sector and one is called agriculture sector. And each of the sector in economics means industry. You could just treat it as an industry. So manufacturing sector means manufacturing industry, like producing goods, the industry for producing goods. And the agriculture will be like farm. The worker will be farmers. All right, so manufacturing sector, agricultural sector means manufacturing industry and agricultural industry. And both of them use two production input. Okay, so production input means that's the things you have to put into your production so that you could get your output of your production process. So both of the sector use one common production input, which is labor. So labor are commonly used in manufacturing sector and agricultural sector. However, in manufacturing sector, there is one specific factor called capital. Okay, so capital, you can treat it as like equipment for the factory. Okay, think about it. You are going to build up a computer factory. You need to have like the machine that building the motherboard. You need to have the machines to build up the chips. You need to have the machines to build up the keyboards, and you also need some of the like platform to let your workers to assemble all of the parts. Right? So capital just means you could treat it as a equipment. And that is specific factor to the manufacturing sector. And agriculture, on the other hand, has a specific factor too. That's called length. Okay, so that's the basic setting. And by this setting, we can get the production in the specific factor model right now become diminishing returns. So in contrast with the Ricardian model that we always assume the production possibility frontier as a straight line. Now, in specific factor model, instead of being a PPF looks like this. This is a Ricardian model's PPF. Instead of looking like this, we are assuming the PPF in specific factor model look like this. So it's a little bit concave to the origin. So we have, this is shoes and this is computer. Okay, and why this one is a diminishing return to scale. So let me just go back to this diagram and show you a little bit what is this meaning. So on the left-hand side, the left column, this is the total production of the labor. Okay, so QM here is the total output of the manufacturing. Okay, but it is the same for either of the sector. If you put LA in the horizontal axis, this one will be QA. All right. So now I see my total production function look like this. So it's increase, but it's increasing a decreasing rate. How do I know it's a decreasing rate? Think about that. If I have additional input of the labor, this is the first one I get for my marginal product. What about the second labor? This is my second labor's marginal product. And the third labor's marginal product is like this. So as you can see, or even though this one is not very obvious, the marginal product decrease as your labor hiring increase. And that is because of what? That's because of a very basic assumption called diminishing return to scale. Means if you have the fixed amount of the capital, okay, so capital is fixed. Labor you hire, the marginal productivity, okay, somebody just drew, marginal productivity of labor will decrease as the labor increase. An example, we have already discussed this last week, on Monday. It's because, like the first one might be very helpful to your factory because the machines need people to control it, right? People need to steer the machine. Somebody needs to press the button. And the second one will be productive as well, but probably less productive than the first one. And if you hire more people, some people become redundant. And after all, maybe marginal productivity of labor become negative. So that will let your total productivity decrease like this. Okay? So that's basically the idea of the specific factor model. So, like I said, this is the PPF. Once again, this is our old friend. And this frontier is the PPF, production possibility frontier, right? And the slope, once again, is the marginal productivity of labor for the y-axis first on the numerator, divided by this. And this is also the opportunity cost to producing one more unit of QM, right? So everything is identical to the Ricardian model. The only one thing is this slope actually change. Right? So this slope actually change when you are in a different production point. If you think about the Ricardian model, what is the linear PPF telling you? Not the slope on the straight line. Okay, the slope on a straight line, it's a constant. It remains all the same. Right? However, in the specific factor model or the actual model we are going to take a look today, this slope, the opportunity cost of additional output of the horizontal axis goods, are going to change depending on which points you are in right now. Okay? And then we're using what? We're using equilibrium equation like this. We're telling you why wage is going to be the same across the industry. It's because of labor. It's a commonly used factor, right? If wage in the manufacturing is larger than wage in the agriculture, the labor will flock into the manufacturing sector, so that manufacturing sector's wage will decrease because the labor in that industry become excess supply. On the other hand, if this is the case and the labor move from the agricultural sector to manufacturing sector, that will decrease. Hold on. Yeah. Okay. I got a question. Hold on. That will decrease the labor supply of the agricultural sector. So once you decrease the labor supply of the agricultural sector, your wage will go up. Okay, so that's the reason why this equilibrium hold. And I just got a question that P is the price. That's exactly right. So PM, what's the notation of this one? Very good. You guys have to ask the question and let me know if anything confuses you. Okay, so this is price. Okay. Yeah. So Audrey, hold on a little bit for your question. Yes. So price PM here. It's the price of manufactured goods. Okay, so what does this one mean? If we step back a little bit, what does just this one mean? So wage, it's equal to the price of the manufactured goods times the marginal productivity of labor in the manufacturing sector. Right? So this is from the perspective of whom? From a firm. Right? So what's this? This is firm's cost. Why is this one's firm's cost? Firm pay the wage to produce the goods. Right? On the right-hand side, PM means the price of the goods. And what exactly is the MPLM? It's the quantity of the goods. Right, so additional hiring labor brings you how much? So this equation are going to hold. So this is firm's cost. This is firm's revenue by hiring additional labor. Did I miss any questions? Let me take a look over this chat room. Okay, no. Yeah, just let me know anytime if you feel confused about the notation. Okay? And then we keep moving on to decided no-trade equilibrium and trade equilibrium, right? So where's the no-trade equilibrium? What is the characteristic of the no-trade equilibrium? No-trade equilibrium is characterized by the green lines here, right? This means the PPF, and this is my indifferent curve. And this is gonna be my no-trade price vector. Okay, so my production and consumption goods are all in on point A, because of what? Because how much I produce is how much I have to consume. right? No trade condition means produce has equal to the consumption. So the maximum level of the utility has to be a curve that is tangent to the, okay, tangent means just cut on one of the point. Okay, it has to be a tangent to the production possibility from here. All right. But once I open up my borders, once I started to trade with the other country, what do I have to do? First of all, the price factor will change, right? So in this case, because home country are going to produce the things that manufacture, right? So the home country is going to produce the manufactured goods, because they have more they have a comparative advantage on the manufacturing goods. So their new production point is here, right? So this is the production bundle of the home country. So this point, it's the production function. Oh, sorry, production bundle for home after the trade. After the trade. And where is the consumption point? Will the consumption point be here? The answer is no, right? Because if you are a rational consumer, you are going to you are going to make your indifferent curve toward the northeast corner as much as possible. So this is your production point, and this is your final consumption point after the trade. Okay, so now you see after the trade, what's the difference? The main differences between the before and no trade and trade scenario. The first one is the relative price, it's different. And the second one is the production, it's not equal to the consumption point anymore. Let's see. So now this is your consumption point. This is your production point, right? So you produce QM here, and you produce QA here. However, you consume QM fine here, and then you consume QA fine here. So as you can see, the production and the consumption, they have a difference, right? Let's take a look of the goods that home country have the comparative advantage, the manufacturing output here. QM, the manufactured goods. Production is larger than the consumption. So what should home country do? If you produce more and you consume less than you produce, you are going to export this good, right? On the other hand, if this one, we take a look at the agriculture goods, this is your amount of the consumption of the agricultural goods, and this is the amount of the consumption, amount of the production of your agricultural goods. You still see there's a differences here. But this time, in home country, you consume more agricultural goods than you produce. So what is this interval we are going to call? We're going to call import. All right? So this triangle, we have a name in economics called trade triangle. In two-country model, all kind of a two-country model, trade balance, it's always apply. That means what? The import value the import of the home country are going to be equal to the export of the foreign country. By the same token, the export of the home country are going to be the import of the foreign country. Another important thing in specific factor model is that the country, either of the country, does not specialize perfectly anymore. Remember, in Ricardian model, where is the point that they produce? Either be here or here. Because of their PPF, it's a straight line. But now, due to the specific factor setting, so then it's going to belong to the agriculture. Capital only belongs to the manufacturing sector. The PPF become a curve, so that right now, after the trade, the country, either of the country, will produce both of the goods as well. They will just change their production bundle, but will not perfectly specialize. So there's a question, so in Ricardian model, that the countries are always specialized. The answer is yes. They specialize in the industry, in the goods that they have the comparative advantage. Okay, so I will just, because this is almost the same for the foreign country, so it's the same logic, same idea. I won't go over one more time. So I want to start with this model. Hold on. I want to start with this model. Okay. So what does this model mean? This model are going to tell us what is the equilibrium wage of the worker in the home country. Okay? So equilibrium wage, originally it's here, and it's determined by what? By two sectors, labor, two sectors, labor market, okay, labor market. It also means it's the marginal productivity of labor curve. So think about that you are in a country, and the workers, they have only two choices to work. They either work for agricultural sector or they work for the manufacturing sector. And as we already know, the MPL, marginal productivity of labor, due to a diminishing return to scale assumption, are going to look like this. Right? So MPLM going to look like this. So if I assume that the price of the goods, it's a constant, okay, so now I just assume it's a constant. What does this curve looks like? This is going to be like, the shape is going to be like this, once again, right? You just times the constant. That won't change. Okay? But we all know that after the trade, okay, hold on, sorry. Okay, so this is the first part of the sector. And I have another sector, right? So I have another sector, it's called agriculture sector. Agriculture sectors, MPL times P could also be, say this, right? And in order to determine the equilibrium wage, I need to do one more trick. That is to flip this one to make it labor hiring increase here. This is just a conventional way, like a convenient way for us to figure out the equilibrium. So the horizontal axis means the total endowment of the labor in home country. If you start with the agricultural sector, you need to start with this point. On the other hand, if you take a look at the manufacturing sector, you have to start with this point. Okay? So think about that. Why this one is the equilibrium of the wage? Why this one is not? This one is not is because at this point, when Lm is equal to this interval and La is equal to this interval, means what? Means the value of the marginal productivity of the labor in agriculture is larger than the value of the marginal productivity of the labor in manufacture. So what will happen? Because labor, we assume labor can move freely across the sector, and they don't need to acquire additional skills to move around the sector. So farmers could be the worker in the factory immediately, and the worker in the factory could go back to be a farmer immediately. So what happened? If labor is here, means the value of being a labor in agriculture, being a farmer, is larger than the value of being a worker in the factory. So of course, people will move from manufacturing to agriculture, right? So this is my original labor hiring in manufacture. And this is my original labor hiring in agriculture. Sorry, this is the manufacture and this is the agriculture. So now labor will move from a manufacturer to agriculture because the value, the return is higher. So Lm will decrease, La will increase. So that shift this line close to the equilibrium point. And it's the same logic for, where's my eraser? It's the same logic for, hold on. It's the same logic for another side. If currently I have my labor equilibrium here, what does it mean? It means I only have this amount of the labor in manufacture, but I have this amount of the labor in agriculture. But this is the equilibrium. Is this the equilibrium? It's not, because their values are different, right? Being a worker in a factory earns more than the worker in the agricultural sector. That means a worker earns more than a farmer at this time. So if there's no barriers move across the industry, workers from a manufacturer could transform themselves, become a farmer easily. It's opposite. The farmers could transform themselves to the workers easily. In this case, they will do so. Right? So that the labor in the manufacturing will increase and the labor in the agriculture will decrease. So this is the equilibrium wage, equilibrium hiring for a country. This is just similar to the demand and supply, like what's the excess supply, what's the excess demand, and what drives the price goes up, what drives the price goes down. The only difference, this is the labor market. Okay, so based on this, talk about the trade. We know that trade will change. The trade will change the price factor. So we assume what? We assume if PM goes up, right? But remember that PM goes up actually means the price factor goes up if we assume PA holds the same. When we are in the two-country model, this is something always looks at, right? The relative price. But in order to determine the home country's wage equilibrium, we only look at the numerical term here. So PM goes up. What happened to our graph? PM. Okay, yeah. So this, the value of the workers in the manufacturing sector, they will shift up, right? Because right now PM increased to PM+. So another representative one is this, or you could write PM. So what happened? Once again, we find the equilibrium. We already know that the intersection of these two lines, this line and this line, it's weird, my eraser is gone. I found it. Okay. So the intersection of this line and this line are going to be my equilibrium wage and equilibrium employment, right? And now, since the factor relative price moved due to the change due to the trade, now I shift up the PM times MPL shift up, so that the equilibrium wage will shift up. Okay, remember what? Remember that the change of the PM will always larger than the change of the wage. And you can see from this diagram, this is the change of the price, and this is the change of the wage. Okay? So I think this is where we left on Monday night. So let me just give you a numerical example here. Yeah, go ahead, Jake.
Yeah, Professor, just going back to the last point you said, did you say that the change of wage will always be greater than the change of price, or were you just saying in that model?
In this model. In this model.
I thought I heard you say always. Okay, I thought you said always, and then No.
Yep, just in this model. That's a good clarification question. Thank you.
Yep.
No, you're right. Only in a specific factor model, and this is very important characteristic in this model. We will see in the numerical example in a second. Thank you for the question.
Thanks, Joe.
It's only in this model. You're right. Only in this model. It's because capital only belongs to the manufacturing sector, and land only belongs to the agricultural sector. Right. So let's do a little bit of the numerical analysis, and that hopefully it will make more sense to you. Okay, so let's define two things first. So QM is the output of the manufacturing. Okay, so this supposed no problem, right? So QM is just the output of the manufacturing, and QA is the output of the agriculture. The revenue earned in each industry is this. Why is that? That's very straightforward, right? How much you produce times how much is your price per unit. These are going to be your revenue. right? By the same token, PA times QA is the revenue in agricultural sector. Okay? So we know that if you are the firm, or you are the entrepreneur, you are the owner of the factory, or you are the owner of the land, what you are going to do, you are going to hire labor, and you are going to put the capital into your production. Right? So if you are a rational factory's owner, you are going to have this equation holds. Payment to capital. Right? Because you only have two production input. That is the common production factor, labor, and the specific factor here. So in the manufacturing, it's capital. Right? So if you do a little bit of the algebra, PM times QM minus the labor's cost to the labor, that's equal to the payment to capital. Right? So we will give this term like a couple new notation later on. Take a look at the agricultural sector. Again, if you are the owner of the land, okay, and you try to hire some of the farmers, and this is your revenue, price times the total product, equals to the cost that you hire the labor, hire the farmers, plus the payment to land. Right? So later on, if we have the return of the land is equal to this, times the value, the quantity of the land is equal to T, so that will be the equation we could see later on. Is this clear? So the return of the land, if you do a little bit of the algebra, put this one in the left-hand side, divided both sides by T, you are going to have P, and this is PA times QA minus W times LA. Is this clear? Okay. Yeah, so it's the same thing applied to the manufacturing sector. Okay, so I don't want to go over again. So manufacturing sector, RK is the return to the capital or the payment. I think it's return. What's the book say? Rental on the capital. Yeah, rental on the capital. RK is equal to PM, manufactured goods times QM divided minus W times LM divided by K. Okay, so this is exactly the next slice we will see. Right, so we call these two terms RK, the rental on the capital, and RT, the rental on the land. That's just the notation. So by definition, it's what? A rental on the capital is the earnings of 1 unit of the capital. The earnings, the returns, right? So sometimes we call returns. The earnings of 1 unit of the capital we call RK. earnings of one arcade of the land we call RT. Right? And I already showed you how do we derive this. Then we need to think about what happened with trade. What will trade affect the rent, the rental on the capital and the rental on the land? So think about that. The logic behind this is, as more labor is used in manufacturing, the marginal product of capital will raise because each machine has more labor to work it. Okay, it seems a little bit of strange, because I told you what? I told you labor increase, MPL is supposed to decrease, right? But what happened here? What's the meaning here? What's going on here? We are looking at which part? We are looking at the marginal product of capital. Instead of labor, we are looking at marginal product of the capital here. So think about that. You own a fixed amount of the machine, and you hire more labor in the beginning of your production. In the beginning of your production, so that will the first one will. So say that one machine at least needs one worker to control it. So the first labor come in, the machine's marginal productivity will increase. The second one, you become more handy, your productivity will increase higher. So the marginal product of the capital will increase, will rise because of more labor join your production. So on the other hand, if the workers move from the agricultural sector to the manufacturing sector, the marginal product of the land will fall. Because of what? Because the fixed amount, the fixed arcade of the land are still there, but there's less of the farmer. So farmers move from the land to the factory. So the marginal product of the land will decrease because the labor move out. Okay, so that gives us a very important conclusion here. An increase in the quantity of labor used in an industry will raise the marginal product of the factors specific to that industry. So what is in this case? What is this one in this case? This is going to be capital, and the industry are going to be manufacturing. Right? On the other hand, a decrease in the labor will lower the marginal productivity of the specific factor. Okay, so in this case, if the workers move from to manufacturing, the decreased marginal productivity of the specific factor is what? It's the land in agricultural sector. Okay? Is this clear? That's because the special setting of the specific factor model, we have one common production input, which is labor, and we have two specific factor, which is the fixed production input, it's the land and capital. So, with labor living agriculture, the marginal product of each acre falls. So RT over this will also falls. Right? So marginal product of each acre is this. Right? So this is the rental on land. And if the price of the goods it's holding the same, this drop, this will And this, it's related to the landowner's welfare. What? The rental on the land decrease. Real rental on the land, because divided by the price level. Real rental on the land decrease. So that landowners, their welfare, of course, will decrease. So the landowner will worse off in this case if the relative price of this increase due to the trade. Okay? I just want to give you the